Aided by the gravitational pull of Venus and the Sun, NASA's Parker Solar Probe became the fastest man-made object in history when it launched in August 2018, yet its top speed is still less than 1% of the speed of light. Could a real-life warp drive move us faster? Physicists are working on it. Bill Ingalls, NASA. Science. Science fiction's warp drive is speeding closer to reality. This Star Trek concept ignited a dream that humans could one day travel faster than the speed of light. Now physicists are working to make it so. By Madeline Stone. October 10, 2025. Nearly 60 years ago, the original Star Trek series ignited a dream in the public's imagination, that one day, people would travel the galaxy in ships propelled by faster-than-light warp drives. The idea that future humans could hop in a vessel and arrive at a distant star system that afternoon soon became a staple of science fiction, not just in Star Trek but in dozens of other movies, TV shows, and books beloved by generations of fans. Many of those fans were children who would grow up to become scientists. And today, some of those scientists are bending spacetime itself to bring warp drive closer to reality. The farthest journey in human history is about to begin. For decades, most physicists considered warp drive to be impossible. But in the past few years, theoretical research has suggested that the fictional technology does not necessarily violate any laws of physics, a discovery that has ignited a wave of interest in creating real warp drive technology. And while there are still many practical challenges to work out, in particular, how to generate and harness the immense energy needed, some physicists say it's not outside the realm of possibility. It's amazing how science fiction writers imagine things, and we then figure out they can work, says Alexei Bobrick, an astrophysicist and pioneering warp drive researcher at Applied Physics, a public benefit company that works with governments and the private sector. It's really quite beautiful. From sci-fi to theoretical physics. There's a reason physicists like Bobrick are taking warp drive seriously. The concept isn't actually that far-fetched. Compared with other sci-fi ideas for moving faster than light, like wormholes and extra-dimensional hyperdrives, warp drive is the easiest to make compatible with known physics, says physicist and science communicator Sabine Hossenfelder, who regularly shares new warp drive research on her popular YouTube channel. In science fiction, a warp drive is a propulsion system that creates a bubble of spacetime around a spaceship. That bubble is then accelerated to move faster than the speed of light. Taken at face value, this may sound impossible. After all, according to Einstein's theory of relativity, objects in our universe cannot be accelerated beyond the light-speed barrier. But spacetime itself can bend or warp at any speed. Star Trek science advisor and astrophysicist Aaron McDonald says it's useful to think of spacetime as a fabric within which objects, from stars to spaceships, are embedded. If you wrap your ship in the fabric of spacetime and then that fabric goes faster than light, carrying you with it, that's actually not breaking any laws of physics, says McDonald. Hibernating humans? The race to unlock a sci-fi superpower. This concept had existed in science fiction literature before Star Trek made its debut. It's not surprising that Star Trek creator Gene Roddenberry chose to adopt warp drive versus a more fantastical flavor of faster-than-light travel, according to author and Star Trek historian Ryan Britt. Roddenberry was obsessed with fact-checking as much as he could, Britt says. That wasn't something that existed in science fiction television ever before. But as plausible as the general concept may have been, warp drive was still seen as purely fictional. The problem, McDonald explains, is that distorting spacetime in this manner would take a mind-boggling amount of energy. In a seminal 1994 paper on warp drive, considered the first serious scientific look at how it might work, physicist Miguel Alcubierre devised a mathematical model that would contract spacetime in front of a ship and expand it behind the ship. While the so-called Alcubierre drive could move a bubble of spacetime at any speed, he found that generating a bubble even as small as a few meters in diameter would require an amount of energy comparable to the mass of the Sun. Furthermore, Alcubierre's calculations required the existence of an exotic form of negative energy to make the drive compatible with Einstein's theory of relativity. Unfortunately, negative energy appears to be a purely mathematical concept and not something that seems to exist in our universe, Hossenfelder says. From theoretical to physical warp drives. In the years following Alcubierre's paper, other researchers, including those at NASA, tinkered with his model. Many follow-up papers attempted to reduce the negative energy requirements. Bobrick first learned about warp drive while studying general relativity in college. He found it intriguing. "It sat in the back of my mind for a long time," he says. When Bobrick met applied physics co-founder Johnny Martiri and learned of his interest in the topic, the pair decided to investigate warp drive more closely. Could Jurassic Park really happen? We asked scientists about sci-fi movies. Instead of tinkering with the Alcubierre drive, the pair decided to start from scratch and see if they could construct a new, more physical, model. They started simple, restricting their analysis to warp drives moving at constant speeds. Alcubierre's drive could accelerate or decelerate, which is more mathematically complicated to describe. In 2021, Bobrick and Martiri published a paper in the journal Classical and Quantum Gravity titled Introducing Physical Warp Drives. In it, they describe the general geometry of a warp bubble with an inner passenger area where spacetime is flat, surrounded by a curved, outer wall that exerts a gravitational field. This stood in contrast to Alcubierre's warp bubble, which does not gravitationally tug on objects outside of it, part of what Bobrick says makes it unphysical. Their model does not require negative energy, however it would still take several Jupiter-sized objects' worth of energy to move a bubble several meters across, Bobrick says, which is prohibitively too much. Yet the bigger caveat of Bobrick and Martiri's warp bubble is that it can only move slower than the speed of light. This may come as a disappointment to Star Trek fans, but physicists say it's still an important step toward moving warp technology out of the realm of science fiction. "Now we have a much better mathematical basis to study warp drives," Hassenfelder said in a video published when the paper first came out. "We know what the warped spacetime looks like. Engage. Making warp drive a reality." Now that scientists have a more realistic model of a warp bubble, the key question becomes finding a way to change its speed. After all, in a hypothetical future where warp drive is used for space travel, bubbles will need to speed up, slow down, and come to a stop to let passengers on and off a ship. Describing that whole process is quite crucial, Bobrick says.